Good morning to everyone. I am Dr. Sumi MS. The topic of my today's presentation is size effect on properties of nanomaterials from Unit 1 Introduction in Nanotechnology. On completion, the students will be able to describe the size-dependent effects on the properties of nanomaterials. Size effect on properties of nanomaterials. Nanomaterials in the range of 1 to 100 nanometer exhibit distinct physical and chemical properties when compared to their bulk materials, primarily due to the factors such as high surface area to volume ratio, quantum confinement, dominance of surface atoms, and these results in size dependent effects on various properties like mechanical, thermal, physical, electrical, and magnetic properties. Thermal properties. It results in reduced thermal conductivity at nanoscale, where phonon scattering increases at surfaces and grain boundaries, and this limits the heat transport, especially in nanowires and thin films. And these have applications as thermoelectric materials for energy conversions. Electrical properties. Increased or decreased conductivity. In metals, electrical conductivity may decrease due to electron scattering at grain boundaries, and in semiconductors, carrier mobility may increase due to the quantum effects. Quantum tunneling. Electrons can tunnel through thin potential barriers in nanostructures, and as a result, these have applications in nanoelectronic devices, sensors, quantum tunneling diodes, etc. Electronic properties. Quantum confinement. Discrete energy levels emerge when the material size is comparable to the exciton Bohr radius, and the band gap becomes size dependent, that is, smaller particles having larger band gap, and this allows tuning of electronic behavior for applications in optoelectronics, and these have application as quantum dots in solar cells, LEDs, as well as display technologies. Mechanical properties have increased strength and hardness. Nanomaterials often show higher yield strength and hardness due to the dislocation confinement as well as grain boundary strengthening. Nanostructures are more resistant to deformation. Example, carbon nanotubes that are 100 times observed to be stronger than steel. And these have applications in aerospace, composites, MEMS, as well as nanomechanical devices. Optical properties. Size dependent absorption or emission. Nanoparticles can absorb and emit light in different colors depending on their size, and they have shift in plasmon resonant frequency in metal nanoparticles such as gold or silver. Color tuning. For example, cadmium selenium selenide quantum dots, the size varies from 2 to 6 nanometer, and respectively there is a variation in color from blue to red. Applications include bioimaging, photodetectors, display technology, sensors, etc. Magnetic properties. Superparamagnetism. Below a critical size ranging between 10 to 20 nanometer, the ferromagnetic materials exhibit superparamagnetism, where there is no hysteresis loss and also strong response to magnetic field and magnetic moment enhancement or suppression due to changes in spin alignment and surface effects, and these have applications as magnetic storage, drug delivery, and MRI contrast agents. Quiz questions on size effects on properties of nanomaterials. Write about the thermal and electrical properties of nanomaterials. What are the optical and mechanical properties of nanomaterials? Thank you.